Hello, lovelies. So in today's lesson, we are going to take a look at motion graphs. First, it's important to remember that all motion can be represented using a graph. Even if that means the object is not moving, we can see that in a graph format. There are a few different types of motion graphs, and we are going to look at two of them. The first one that we look at is called a distance time graph. A distance time graph shows the total distance covered over time. You can actually calculate an object's speed using a graph like this, and that is actually something we'll look at in this video. Then there's also a speed time graph. A speed time graph shows the change in speed over time. You can calculate an object's acceleration with this graph, but we are actually not covering that in this lesson. We'll look at that in a different lesson. So if you notice, they look very similar, but with just a few differences. The first difference is that distance and speed are on the y-axis. So in a distance graph, distance is on the y-axis, and on a speed graph, speed is on the y-axis. This means that your y values will be whatever is listed on the y-axis. However, time is on the x-axis on both of them. So this means that your x values will always be time. You can use a distance time graph to actually calculate the speed of an object. So there's two different types of calculating speed that we're looking at. The first one is to find speed at one point. We look at the graph and we write out our equation first. Then we find our distance or our y value for the point. We find our time value or our x value for the point. And then we plug in our values and we solve for it. So for example, find the speed at point A. Point A is listed here. First, I'm going to write out my equation. Speed equals distance divided by time. Then I'm going to find my distance and time values. So remember, my distance is a y value. I just look at the point and I look at what value it hits on the y-axis. And then I look at my x-axis for time, and I see that it's 10 for distance, 20 for time. So 10 on the y, 20 on the x, and that's where I got my numbers here. Then I just plug in the numbers to my equation, which I already found, and I use a calculator to solve. So at point A, this object's speed was 0.5 meters per second. Now what if you have to calculate speed between 2 points using a graph? Again, it's very simple. We just follow a few steps. So to find the average speed between 2 points, I first write out my equation. Remember, my equation for finding the average speed between 2 points is just expanded, but it's essentially your slope formula. It's your rise over your run. That's all it is. So it's speed equals d2 minus d1, because distance is our y value, and time, t2 minus t1, is our x value. Then I find my distance and time for the first point, so d1 and t1. Then I find my distance and time for the last point, d2 and t2, and then I plug my values into the equation and solve. So for example, find the speed between point A and point B. So point A is here, point B is here. Point A is my first point, point B is my last point, and I'm trying to find essentially the slope. The slope is the speed in this case of the object between these 2 points. So first write out my equation. My equation again was d2 minus d1 over t2 minus t1. My rise, my change in distance over my run, which is my change in time. Then I find my values for my d1 and t1 and my d2 and t2. So d1 and t1 at point A, distance was 10, time was 40, and then at B, distance was 40, time was 60. Then I just take those numbers and I plug them into my equation. I set up my equation form with those values, I simplify, and then I solve using a calculator. So in this example, the object was moving at a rate of 1.5 meters per second between point A and point B. Another way that you can say this is the slope of the line was 1.5. So the last thing that we're going to look at is you can actually use both of these graphs, distance time and speed time graphs, to make inferences about an object's motion, even if you don't know any of the numbers about it. So on a distance graph, If the line is a straight diagonal line, it's a constant speed. And depending on the slope of the line, whether it's a positive or a negative slope, it gives you whether it's going faster or slower. So both of these lines show a constant speed, but the one that has a higher angle is going faster. If it's a lower angle, it's going slower, but it's still a constant speed. If it is a straight line, that means it's not moving. If it's a diagonal line but it's a negative slope, or it's moving down towards the x-axis, it's a constant speed still, because it's that straight line, but it's returning to the original position. If it's curving up, it's speeding up, and if it's curving down, or curving back down, it's slowing down. So make sure you take the time to actually label this in your notes, because this is really, really helpful. This was a distance time graph. But on a speed time graph, it will look a little bit different. So make sure that you just look at the y-axis to see what you're actually looking at. On a speed time graph, that diagonal straight line is not constant speed, but in this case it's speeding up. So it's changing speed at a constant rate. If it's a straight line, a straight horizontal line, that means it's moving at a constant speed. The speed is not changing, but it's still moving. If it's a line, a straight diagonal line moving down towards the time or x-axis, that means it's slowing down. And then if it's a horizontal line on the x-axis, that means it's not moving, because y would equal 0 at this point, and our y value is speed. So again, take the time to label this in your notes, because this is very helpful to refer to. And remember, these graphs just tell a story about the object's motion. So you got distance here telling a story about the an object's speed in terms of its distance traveled over time. And then on a speed graph, you have a story being told about how fast or how the object's motion is changing. That's it. What you're trying to measure will determine which graphs are best. Make sure you look at the y-axis, and that's it. Have a great day, guys.